horizon line all the way across. Find your center of vision. You guys know how to do that. And drop a vertical line straight down from your center of vision. Now, so we have our horizon line in, and find out where your center of vision is. You can certainly label it. Now this will always stay as a center of vision. It will never be a vanishing point for a two-point perspective. And now you can figure out where your vanishing points are. So you're going to get your triangle. This is your 45-90 triangle. You can use both. I mean, you can use your other one too, but it's a little bit easier with this one. So you're going to place this in a way where you can actually capture both vanishing points on your paper. Okay. So, I mean, you can slightly tilt it, which I do recommend, and I'll explain why. If you do slightly tilt it, you get a little bit more room. You might have to use your other triangle to figure out where your vanishing points are to make sure it stays on the paper. So I do have mine slightly tilted, and the reason why is it allows us to figure out where our diagonal vanishing point is without it being the center of vision. Okay, so let me explain. As you guys know, the diagonal vanishing point is at a 45-degree angle from the station point. Okay, so with that said, because this is a 45-90 triangle, if I keep this nice and even here, like this, and have a vanishing point up here and here, you know, if I use my triangle as an extension like this, the inherent problem is the center of vision becomes the diagonal vanishing point 2. Okay, so to avoid confusion, now can you do that? Yes, you can absolutely do that. But the big question comes up is, why is the center of vision and the diagonal vanishing point the same thing? It's not the same thing. It might be located in the same place, but they're two different entities. So what I prefer students to do is tilt it. So tilt it either to the right or to the left. So you still get your vanishing points here on your paper, but then your diagonal vanishing point does not become your center of vision. So I'd like to explain that, you know, right away so you guys understand. What some people like to do is they like doing this. They like placing like their vanishing point like right here at the very edge, right here. And they line this up here, you know, obviously they're using this as an extension. And they're looking at this line here so they don't make it parallel with the horizon line, so they can tell that it's different. And if you put your vanishing point here, that's fine. That could work. But you could also lower it a little bit and still have an angle that is not aligned with the horizon line or not parallel with the horizon line. So some students like doing that, and that's fine. What I strongly recommend is don't make this nice and even. In this world, or in our society, humans, I'm not sure why, they like making everything symmetrical. Nothing in nature is really symmetrical like that, but they want to put things in order. So people naturally do this. So I'm going to ask you to try to avoid doing that. That way it's a little bit easier to learn two-point perspective. So I have mine at a slight angle. And once I figure out what it's going to be, I'm going to place a point down here for the station point. I'm going to label it SP, station point. I will draw a line that goes all the way up to my right vanishing point. I will hold this here. I'll place this 90-degree angle right here at the station point again. And then I'll go on this side and I'll draw my line going all the way up to my left vanishing point. Bless you. I will tell you, students don't like doing it this way. They don't like doing it this way because they want to put everything like nice and neat and perfect. Students love doing this. They like matching it up with keeping it nice and parallel, maybe even bringing it down here. This is what students like doing. They love doing this, and they do it automatically. But I'm going to ask you not to do that. Okay. That way you can place it in a different spot. So let's label these two. This is your right vanishing point. You can label it any way you want. I put RVP for right vanishing point and LVP for left vanishing point. If you want to label it VPL for vanishing point left or VPR for vanishing point right, you can do that. So basically this is what it looks like. Now, I will tell you that the cone of vision is small. And the reason why it's small is because we're using a fairly short distance for the station point. So this is the width of the actual cone of vision. We're going to draw today to we're going to kind of disregard it for now. It's not terribly important for what we're going to do today. But on Thursday, or maybe even today, we'll make a bigger one. But for now, we'll just use this one. This is a very conservative, structured approach in two-point perspective because everything remains in the within this sheet of paper. So again, fairly conservative. Now, let's figure out where our diagonal vanishing point is. Let's at least do that. So we have our really big 10-inch triangle. At least we should. I know some of you don't, and you're gonna wish you had one. Okay, so you're gonna get this, and all you're gonna do is you're gonna rotate it so it does this. I gotta bring my straight edge down, I apologize. So you have it like this, and all you're gonna do is you're gonna put the short end here. So you're gonna put the tip, or the 45-degree angle, right here at the station point, and line it up on one of these reference lines. A reference line is one of the lines that goes to both vanishing points. Okay, so I have it lined up here, which gives us, this is a 45-degree angle here, and it lets us know exactly where our diagonal vanishing point is. As it crosses the horizon line, that becomes our diagonal vanishing point. And again, this is a 45-degree angle here, so I'm going to write 45 degrees here. So this is incredibly important. You cannot make up where your diagonal vanishing point is. Your diagonal vanishing point is always at a 45-degree angle from the station point regardless if you're doing 1-point or 2-point perspective. In 1-point and 2-point perspective, they are located in different areas, but we still use a 45-degree angle here at the bottom, at the station point. We line one side up with the short end of this triangle. We line it up on the reference line, and we put a 45-degree point right on the station point and draw that angle all the way up to the horizon line to figure out where exactly our diagonal vanishing point is. Right there. All right, so we have our sheet of tracing paper taped down. I'm going to go ahead and put my horizon line in. Remember, the reason why we do this is so we can preserve our structured approach and we can use it multiple times. And certainly indicate where the diagonal vanishing point is. And of course the center of vision. You can keep this really, really light though, this line. With this, I will ask you to draw these reference lines in as well. And I would like you guys to get in the habit of doing this, because if you ever leave class and you're working on stuff at home and these two sheets of paper get separated, you can easily put it back together by these reference lines or the diagonal vanishing point. Just makes it a little bit easier. And of course this the distance line. Okay, in 2-point perspective, it's super, super easy. We're going to take baby steps. The title of this drawing will be 2-point basic constructions. Okay. So we're going to do some basic planes first. We'll do some horizontal and vertical planes, and we'll also combine them. We will also overlap them. So keep your lines light. We will modify these. So just pick a point and then draw lines converging to both vanishing points. You could decide how big this plane is going to be. I'm going to suggest that you don't make it too big, but don't make it too small either. You have a fairly large sheet of paper. Again, we're in many ways just going to disregard where the cone of vision is for now. The kind of drawing that we're going to do today is not terribly important to make sure that everything is within the cone of vision. So again, you guys know how to do this basic 2-point perspective planes. So again, you pick a point, draw a line converging to both vanishing points, decide its depth on both sides, and then draw lines converging to both vanishing points. So there's no real magic with this. It's just you have two vanishing points. This is no longer a vanishing point. This is not in two-point perspective. So the big difference when you look at a two-point plane versus a one-point plane is it's not parallel to the horizon line at all. Now, perspectively, it is parallel. But because the corner of this plane is closest to the viewer, none of these lines can actually be parallel with the horizon line at all. So I want you guys to do 5 of them. 5. You can do some above and below the horizon line. You can duplicate them if you want to. You can align them together. In fact, I need to use my other straight edge for this. So again, they can be any size. So again, remember, you pick a point, draw a line, converge into both vanishing points. Okay, similar to what you did in your beginning drawing class. So I'm going to overlap the other two. I'm going to pick a point here. This one's going to be kind of big. This one's going to be a little bit bigger, rather. So this one is overlapping this one, or this one's overlapping this one. I haven't figured that out yet. I'm just going to leave it for now, and I'll define it a little bit later. So with these, I'll start modifying them. I'll start cutting pieces away. I'll do it to a few of them, and then after that I'll move on. So to create the vertical planes, it's the same way that we did it in one-point perspective. You do need your triangle. It doesn't matter which triangle that you use. But it does matter which vanishing point that you use. That way we can tell what direction it's going in. It's either going to converge to the right vanishing point or the left vanishing point. But it can't be both for a single plane.